Welcome to my second lesson on differentiation. Lately we looked at definition for differentiation. We also looked at derivative of a polynomial. This time round we look at equations of tangents and normals. We're going to define and look at examples in that regard. And so let's begin. Equations of tangents and normals. Now, tangent of a curve at a point is normally a straight line whose gradient is equal to that of the curve at the given point. The tangent only touches the curve, it does not go in. It's fair to say that it only touches the curve once. That's why it doesn't go in anyway. To illustrate that, I have a curve for you here. We have this curve and we have the point P, XY. That's the coordinates there. And we have a line like that. We say that this line is a tangent to the curve at the point P because the gradient of this curve and the gradient of the gradient of curve and the gradient of the tangent are identical at the point P. Again, the tangent just touches the curve and does not go in. What I mean by does not go in is because it doesn't intersect the curve at 2 points. It doesn't cut the curve anywhere. It only touches the curve once at the point P. Therefore, that is a tangent. Let me say that the equation of the tangent at the point P can be found using y is equal to mx plus c. And that's really, really important. It's assumed that at this point, students should be able to know what y is equal to mx stands for. It's the equation of a straight line where m and c are constants, m representing the gradient of the line, c is the y-intercept. Now, the m, which is the gradient of this particular line, is equals to differentiating the function of this curve, and that means that if we found the derivative of this curve, it should be numerically identical to m, and that is a concept upon which we anchor everything we are going to do with equations of tangents and even use it for equations of normals. Let me go to the next part. Normal to a curve. Let me say that normal to a curve is normally a straight line perpendicular to the tangent of the curve at a point. So when you talk about a normal to a curve at a point, is that straight line that's perpendicular to the curve, to the tangent of that particular curve at the particular point. In our case, point P. For example, we have a line like that which is perpendicular to the tangent. That becomes normal. If it's perpendicular to the tangent at the point P, is a normal of that particular curve at the point P. Now, equation of the normal at the point P can be found using y is equals to mx plus c, and we shall look at that in a few moments. Let me say that the gradient is such that m1 times m2 is equals to -1, where m1 is the gradient of the tangent of the tangent being m1, and m2 being the gradient of the normal, and therefore that's the case there. To tie this together, I want to say this: the gradient of the curve and the gradient of the tangent at the point P are equal. Please master that. Also, please understand that the tangent and the normal are perpendicular at the point P. These are the two major concepts that I want us to always remember as you attempt questions on this particular manner, and I think that will be helpful for you. Let's go to the first question as an example. We're given the equation of a line of a curve y is equal to x cubed plus 6x squared minus 3x plus 1 to determine the equation of the tangent and the equation of the normal at the point to the curve at x is equal to 0. Now, starting with the equation of a tangent, I want to say this: when x is equal to 0, we need to get the value of y, and it's 1. And this is very easy because you just put the values of x here to be 0. X being 0, x being 0, x being 0. Therefore, this will be 0, this will be 0, this will be 0, but only after the equal sign, the only thing that remains is 1, and therefore y is 1. So we now know that the point we're talking about is a point 0, 1. It is necessary for us to get these two because we're going to use the coordinates, xy coordinates, to look for the equation of the tangent, the equation of the normal. Now, I have plotted the curve for you, and there it is. The point is this and here, and therefore the line we have there is the tangent of that particular curve at that particular point. And please master that the gradient of the curve equals the gradient of the tangent, the point 0, 1, as we continue. Since we are looking for the equation of the tangent, we should progress this way. We'll say that this being a straight line, its gradient m equals to the gradient of that particular curve at that particular point, according to this particular statement. The gradient of this line and the gradient of the curve at the point 0, 1, they are equal. Therefore, we can look for we can differentiate this function here, which is this one here, and it must be equal to the gradient of that tangent at that particular point. We also know that the value of x here is 0, all right, because the coordinate is 0, 1. The value of x here is 0. So putting the value of x to be 0, we get m is negative 3, and therefore the gradient of that tangent is negative 3. Now, for y is equals to mx plus c, we know that m will be negative 3, x is equals to 0, and y is 1. Let me define that. This is the equation of a straight line, which we're going to look at for the particular tangent. The m is what we've just gotten, is negative 3. X is the x coordinate, and the y is the y coordinate, which is 0, 1, respectively. Put those values in the formula, therefore, and you're going to have y is 1, m is negative 3, x is 0. The only unknown we have there is c, sorry. And we're doing this so that you get the value of c. So simplifying that, you get 1 is equals to c, or if you like, c is equals to 1. Put the values in the formula, you get y is equals to negative 3x plus 1. And there you have it. The equation of the tangent to the curve, y is equals to x cubed plus 6x squared minus 3x plus 1 at the point 0, 1. I think that's clear. The equation of the normal, we should know that the normal is this particular line that is perpendicular to the tangent at the point 0, 1. Okay? The gradient, let me call it m2, is a third. It's because it's negative reciprocal of m. Negative, so it becomes positive. Reciprocal, so it becomes 1 over 3. And therefore, it's a third. For y is equals to mx plus c, we have m is a third, what we've just said there. The x remains the same and y remains the same because we are looking for the normal equation of the normal at the point 0, 1. So x is still 0, y is still 1. So put the values in the formula this particular way. You get c is equals to 1. Therefore, the equation is 1. Y is equals to a third x plus 1. And I think that's easy, even simple. We proceed to another question. For the equation y is equals to x cubed minus 2x squared minus 1, determine the equations of the tangents and the normals at y is equals to negative 1. We begin again with the equation of the tangent. We need to do the following. 1. We look for the value of x for which y is negative 1. We don't know what value of x is. Again, I should say that we need the coordinates of the xy coordinates so that we can proceed to operate the equation of our tangent and normal as we've done in the previous example. And therefore, when y is equals to negative 1, we have a scenario like this. This here is replaced by negative 1, and therefore everything else is remaining the same way it was. We have negative 1 appearing on both sides of the equal sign, so you can know that taking negative 1, the other side becomes 1 minus 1, which is 0. So you have 0 is equals to x cubed minus 2x squared. This is a cubic equation which should give us 3 answers for x, and we should proceed as follows to solve that. First of all, you will need to factorize out. You have x squared in brackets. We have x minus 2, and therefore we can say that either 0 equals to x squared, or and therefore x is 0, or we have 0 is equals to x minus 2, and therefore x is 2. Now it looks like we have 2 answers here, and yet we have a cubic equation which we are solving, and we anticipated to get 3 answers. I should say that when we have 0 is equals to x squared, it tells us this is a repeated root. So it's the same way, the x minus 0 is the same way of, we can say that it is x is equals to 0 and x equals to 0. So that we have 2 values of x which are same, which is 0. So please understand that these are written as 2 answers, but they're actually 3. X equals 0, and x equals 0, and x equals to 2. Now, proceeding on to drawing the curve, we have it there. I actually don't think it's necessary for us to plot the curve, but for the sake of explanation, it is necessary. I don't think it is necessary for an actual exam question, unless you're required to. Now, we have 2 points. We have the point 0, negative 1. The 0 is that one there, and y is -1. So we have the first point 0, -1, which is a turning point. No wonder we have the repeated root. We had another point 2, 0, which is that particular point there. We are looking for the tangents, one for this point, one for the other point, and normals, one for this point and one for the other point. And we are looking for the equations of those normals and tangents. Let me say that the gradient of the tangent, the gradient of the curve and the gradient of the tangent are identical at these 2 points. And as we proceed, I should say this: there's a normal like this through the point 2, 1, whose gradient equals the gradient of that curve at the point given. Similarly, we have a tangent like this, whose gradient is equal to the gradient of a curve at that particular point. I mentioned it's a turning point. We shall be looking at that in the next lesson. And I should say that turning point, the gradient is 0, so we know a lot already about this particular point, and we shall look at that as we proceed. Now, since the gradient of the curve equals the gradient of a tangent at those 2 points, we should first of all have the general equation for the tangent, sorry, for the derivative or differentiation of this one, so or the gradient of the curve actually. So we have changing y, have changing x is equals to, differentiate this, you get 3x squared minus 4x. We have this answer numerically. When x is equals to 2, x equals to 0, we put the value of x to be 0 here, we get the gradient is actually 0. It's a turning point, remember, so the gradient is 0. Again, when x is equals to 2, this value numerically will be 4. So what we are saying is the gradient of this curve here at point 0, -1 is 0, which is the gradient of the tangent at the same point. Again, the gradient of this curve at the point 2, -1 is 4, which is the gradient of the tangent at the point. So we proceed now. The gradients of the tangents are 0, first of all, for the point 0, -1. I've just said that because that's the gradient of the curve at that particular point, and also equals to 4 at the point 2, -1, because this is the gradient of the curve equal to the gradient of tangent at the point 2, -1. Therefore, using y is equals to mx plus c, we have m is equal to 0 for the first case. M is 0, the gradient of the tangent is 0, x is 0, and y is 1. Putting those values in the equation, you solve and you get -1. C is equals to -1. Putting that in the equation, we have y is equals to -1. Well, we can see it's a horizontal line anyway, and it doesn't have a gradient. Cuts the y-axis -1. Therefore, it's simply y is equals to -1, and there's no much you can say about that. Similarly, we can say that for y is equals to mx plus c, we have, for the second case, m is 4, x is 2, there's 2 here, this second point, the x is 2, and y is 1, y is, -1, and therefore putting the values in the formulas, you get c is equals to -9. How that's right? You have 8, take the other side, you get -1 minus 8, c is equals to -8, so the answer actually becomes this particular one. I hope that's clear. We go into the second half of the question, which is the equations of the normals. Now, they are as follows. First of all, the gradients of the normals are, we have the normal is a line perpendicular to this one here. This was a tangent. Normal is perpendicular to that at a particular point. We also have another one that is dropping there. I hope you can see it. This line here is perpendicular to this one, and therefore those are normals to the tangent, to the curve at those particular points. So the gradients of the normals are, first of all, the first one is undefined. It's undefined because it's perpendicular to a horizontal line. And now we know if it's perpendicular to horizontal, it's vertical, and gradients of vertical lines are normally undefined. For the first point, that was, and for the other point, we have it's -1/4 for 2, -1. Please understand that the gradient of the other one being 4, the gradient of this particular normal is negative reciprocal of that, which is -1/2, sorry. And so we proceed as follows. For the first case, the gradient is undefined and the line passes through the point 0, -1. It means that it's a vertical line and it touches the x-axis at 0, and therefore the equation of the line is x is equals to 0. There's no much I can say about that. Let me say this though. The line being vertical, and is vertical passing through the point where x equals 0, this we can only conclude that the equation is x is equal to 0, which is the y-axis. Going to the second part, we say for y is equal to mx plus c, m is negative a quarter, it's given here. X is 2 given there, y is negative 1, and therefore putting the values in the formula you get c is equals to negative half, so the formula will be that particular one there. So the equation of the second tangent, sorry, the second normal, this normal here, is y is equals to negative a quarter x minus half, and I think that's clear. Let's go to the last question. Find the point on the curve y is equals to x squared minus 3x plus 7 at which the gradient is 5, and also find the equations of the tangents and the normal at that particular point. Now, what this information in the question tells us is that there is a point for which the gradient of this curve is 5. It's a quadratic curve. There's a point where the gradient is 5. Look for that point, and then look for equations of the tangent and normal at that particular point. Therefore, we proceed as follows. First of all, we know that differentiating these gives us the gradient, and we're saying that that gradient is 5. Therefore, the change in y or change in x is equals to 5, and therefore we have that equals to, differentiating this becomes 2x minus 3. And so I've just written there that 5 is equals to 2x minus 3, and simplifying for x you get this 4, because you take negative 3 the other side, you have 5 plus 3, which is 8, and therefore we have 8 is equals to 2x, and therefore x is 4. Similarly, we want to get the value of y. We use the parent equation. Y is normally given by x squared plus minus 3x plus 7, so you put x to be 3, get 16 minus 12 plus 7. Y is 11. All right. Therefore, the point we're talking about, where the gradient of this curve is 5, the point is 411. I have drawn it for you. So we have, it's a quadratic curve, it's turning that particular way, and the gradient is 5 at this particular point. Now, the gradient of the tangent, we begin with that, and this is what we say. First of all, the gradient of the tangent is 5, because normally the gradient of a curve at a point is same as the gradient of the curve at the point. Therefore, it's 5. That is a tangent. That's a tangent whose gradient is 5, and the point is 411. So we proceed this way. Y is equals to mx plus c. That's the equation of the tangent we're looking for. Therefore, m is 5, x is 4, y is 11. Where do you get those ones? The gradient of the tangent, the gradient of the curve are the same, and they are 5. X is 4 for this point, and y is 11 for 10 point. Therefore, put these values in the formula. You get c is negative 9. We have 11 minus 20. Yes, c is negative 9, and therefore you can solve that particular one there. This should not be plus or minus, should be minus 9. Therefore, the equation should be y is equals to 5x minus 9. Please remove the positive, it's not right. We proceed to the equation of the normal. The equation of the normal should be looked at this way. First of all, it's a line that's perpendicular to the tangent at the point 411. The gradient is negative reciprocal of 5, which is negative a fifth. For y is equals to mx plus c, we have m is negative a fifth, and x is 4, y is 11. The same figures you have there, because that's a point we are looking for. That's a point through which the normal passes. Therefore, we can have 11 is equals to negative a fifth in brackets 4 plus c. Remember, this 11 is the y, which is this one. Negative a fifth is this particular one, and 4 is that particular one. Remember also, this is the same as this particular equation, just in case I need to mention that. C is 51 over 5, and therefore the equation is y is equals to negative a fifth x plus 51 over 5. And I think that's clear. Again, please let me mention that this is not right. It should be y is equals to 5x minus 9. C is minus 9. You should not have plus or minus. Yeah, and having said that, I have come to the end of my lesson today. I hope you enjoy it and find it helpful. Use the same concept to operate questions that have to do with the tangents and normals. Please like, subscribe, share.